Hello, in this lecture we'll answer on two questions. On both questions, we'll find out the area of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. ABCD is a quadrilateral because it has four sides, and side AB is parallel to the opposite side DC, and therefore this quadrilateral is defined as a trapezoid. And the two parallel sides, that is to say AB and DC, are defined as the basis of this trapezoid ABCD. So if we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid ABCD will be equal to the sum of its two parallel sides, that is to say A plus B times the height h over 2. So the area of the trapezoid is equal to the sum of its two parallel sides times the height h over 2. The height h must create 90 degrees with the two parallel bases. So, repeat again that a trapezoid is a quadrilateral with one pair of parallel sides. And the area of a trapezoid is equal to the sum of its two parallel bases times the height h over 2. The height h must create 90 degrees with the two parallel bases. So, in the first question, we find out the area of this trapezoid ABCD. It is given us the question that the perimeter of this trapezoid ABCD is equal to 16 units. What is the perimeter of a trapezoid? The perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. Again, the perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. In this trapezoid ABCD, the perimeter of this trapezoid ABCD equals to AB plus AD plus DC plus CB. And you know that the perimeter is 16. So AB plus AD plus DC plus CB equals to 16 units in its length. In addition, we know that side AB equals to 2 units in its length. Those two angles are right angles, and we also know that BC equals to CD. So our mission is to find out the area of this trapezoid ABCD. So first of all, we define the length of side AD is A. And we define the length of side DC as B. According to what is given as the question, side BC equals to side CD in its length. So if DC is B, then BC must be also equal to B because they are equal to each other. So the perimeter of this trapezoid ABCD is 16. That is to say, AB plus AD plus BC plus BC equals to 16 units according to what is given as the question. I repeat again, AB plus AD plus DC plus BC equals to 16. AB is 2 according to what is given as the question, plus AD. AD is A according to our definition. The length of side AD equals to A units according to our definition. So let's substitute AD by A. DC equals to B units in its length according to our definition. So we substitute DC by B plus BC. BC is also B. And it is equal to 16. We subtract 2 from this equation and we get that A plus B is A plus 2B, and it is equals to 14 minus to 16 minus 2 is 14. So A plus 2B equals to 14. Here we will subtract 2B from this equation and get that A equals to 14 minus 2B. A equals to 14 minus 2B units in its length. So the length of side AD is A, and A equals to 14 minus 2B. So write it down, A equals to 14 minus 2B. In the next step, we will do a construction, that is to say, from the vertex V of this trapezoid ABCD, we will do a perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we added there quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this four-piece angle is equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this four-piece angle must be equal to 90 degrees in its size. So inside quadrilateral ABMD, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we need to this quadrilateral ABMD is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AD equals to the opposite side BM. AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. Likewise, according to the sum rule, in the sum rectangle ABMD, side AB must be equal to the opposite side DM, but AB equals to 2 units according to what is given as the question, therefore the opposite side DM must be also equal to 2 units in its length. What is the length of this missing line segment MC? MC equals to DC minus DM. So write it down. MC equals to DC minus DM. So MC equals to DC. DC equals to B units in its length according to our definition, minus DM. Just write down found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. So write it down. MC equals to B minus 2 units in its length. In the next step, I'll copy this right triangle BMC in a new page, and we'll implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right angle BMC that I copied from the original drawing. According to the Pythagoras theorem, in this right angle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared. And we have also plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, if you found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. Here we open the brackets on this side of this equation, and we get that B squared equals to 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared, minus 2 times 14 is minus 28, and minus 28 times 2B is minus 56B. And we also plus put B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2 is minus 4B. So here we have B squared on both sides of this equation, so B squared gets cancelled. After cancelled B squared on this side of the equation, we left with nothing, that is to say 0, while on the other side of this equation we have 196 plus 4 is 200, and we also have minus 56b minus 4b is minus 60b plus 4b squared. So in total, if you found out that 0 equals to 200 minus 60b plus 4b squared. So here we divide this equation by 4, and we get that 4b squared over 4 is b squared, and we also minus 60b over 4 is minus 15b, and 200 over 4 is 50, and it is equals to 0 over 4 is 0. So in total, we actually found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b. So x equals to b, or small b. Small b is the variable that we are looking for, and capital B is the coefficients of this quadratic equation. So the variable that we are looking for is small b. So x equals to small b. The coefficient a equals to 1. The coefficient b equals to minus 15. And finally, the coefficient equals to 50. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of b, because the variable that we are looking for is b, so x equals to b. So we substitute x by b, and we get that b equals to minus b, minus capital B, that is minus 15, and b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a is also minus 4 times 1 is minus 4, times c is 50, so minus 4 times 50 is minus 200, divided by 2a. A is also 2 times 1 is 2. So in total, if you found out that b equals to 15 plus minus so b equals to 15 plus minus square root of 225 minus 200 is 25, so inside the root we left only is 25 divided by 2. So b equals to 15 plus minus, and the square root of 25 is 5 over 2. So here we have two solutions that are possible for b. We will define the first solution for b as b1 and the second solution as b2. So the first solution for b will be b1 equals to 15 plus 5 over 2. So I write it down. The first solution for b is b1, and b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So b1 equals to 10 units in its length. And the second solution for b is b2. b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, and b2 equals to 10. AD is one side of trapezoid ABCD, and we know that the length of AD is A. AD equals to A units in its length, and A itself equals to 14 minus 2B. So A is 14 minus 2B. The expression 14 minus 2B is the expression for the length of side AD of trapezoid ABCD. So it is the expression for a length, and the length must be positive number. What is a positive number? Positive number is a number that is greater than 0. So the length 14 minus 2b is a positive number, therefore it must be greater than 0. So 14 minus 2b is greater than 0. Here we relate to this inequality 2b, and we get that 14 is greater than 2b. Here we divide this inequality by 2 and we get that 14 over 2 is 7, so 7 is greater than 2b over 2 is b. So in total, we found out that b is less than 7 units. So b must be less than 7 units from one side, but from the other side, according to the first solution for b, that is b1 is equal to 10. The problem is that b must be less than 7. B can never be equal to 10 that is greater than 7. Okay, b must be less than 7 units. So b1 is 10 that is greater than 7. So this solution is a correct solution. We cancel the solution. And we have to only with the second solution that is possible for b, that is b2, that is equals to 5, of course. b2 equals to 5. 10 over 2 is 5. So b2 equals to 5. Or we can write that b equals to 5. So the only solution for b is b equals to 5. That is the only solution that is left for b. AB equals to 2, DC equals to b, and b equals to 5. So DC is equals to b is equals to 5 units. And AD equals to 14 minus 2b. B is 5, so minus 2b is minus 2 times 5, that is minus 10. And A equals to 14 minus 2b, that is 14 minus 10, that is 4. A equals to 4, AB equals to 2, and this equals to B, that is 5. So our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases. In this trapezoid ABCD, it is AB plus DC times the height. The height is DC. Why the height is DC? Because of the fact that DC creates 90 degrees with the base. Again, the height is AD, of course. The height is AD. And again, the height is AD. Again, the area of trapezoid ABCD equals to the sum of its two parallel bases. AB is parallel to DC, so it is AB plus DC, of course, times the height. AD is the height. Why AD is the height? Because AD creates 90 degrees with the base DC, and AD also creates 90 degrees with the base AB. This angle equals to 90 degrees, and this angle also equals to 90 degrees. Therefore, AD is the height divided by 2. So in total, we found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, that is AB plus DC times the height AD over 2. AB is 2 according to what is given as the question, plus DC. DC is B, and B 5. So DC is 5 times the height AD. AD is 4 divided by 2. So in total, the area of trapezoid ABCD equals to 2 plus 5, that is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if you found out that the area of trapezoid ABCD is equal to 14 square units. And that is the answer of the question. And again, we have found out that the area of this trapezoid ABCD is equal to 14 square meters. Okay, so we finished with the first question. In the next step, I present to you the second question and solve the second question of this lecture. In the second question, our mission is to find out the area of another trapezoid. It has the same name as the first trapezoid ABCD, but it is totally a different trapezoid. So we have to find out the area of another trapezoid with the same name, trapezoid ABCD. So this is trapezoid ABCD. The length of side AD is 2x, the length of side BC is x, line segment AM equals to 3 units in its length, line segment BM equals to 2 units in its length. This is angle A and B, that is a right angle. Those two angles are also right angles. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we'll define the size of this angle. That is actually angle BMC, is alpha. And we focus on this small right angle BMC. In this small right angle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line DC at point M here, so here the sum of the angles must be equal to 180 degrees, according to rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, plus this angle that is right angle, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M according to rule 3. So this missing angle must be equal to 90 degrees minus alpha. In the next step, we will focus on this big right angle ADM. In this big right angle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. In the next step, we will prove that those two right angles are similar to each other according to angle similarity rule. So, why those two right angles are similar to each other? That is to say, why the right big triangle ADM is similar to this right small triangle BCM. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if you found out that all the triangles of this big right angle ADM are correspondingly equal to all the triangles of this small right angle BCM, and therefore those two right angles are similar to each other according to angle similarity rule. So I write it down. If you found out that this big right angle ADM is similar to this small triangle, this small right angle BCM, according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of this big right angle ADM over side MC of this small right angle BCM is equal to side DM of this big right angle ADM over side BC of this small right angle BCM. And it is also equal to side AM of this big right angle ADM over side BM of this small right angle BCM. So repeat again, from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AD of the big right angle ADM over side MC of the small right angle BCM equals to side DM of the big right angle ADM over side BC of the small right angle BCM, and it is also equals to side AM of the big right angle ADM over side BM of the small right angle BCM. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is equal to DM. DM is the missing side, so we leave it as it is. Over BC. BC is x. And it is also equal to AM. AM is equal to 3 units in its length according to what is given as the question. Over BM. BM is 2 also according to what is given as the question. So in total we have found out that x over MC equals to dm over x equals to 3/2. Those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. So according to equation 1, we get that 2x over MC equals to 3/2. So here we multiply equation 1 by MC, and we get that 2x equals to 3/2 times MC. So here we multiply equation 1 by 2, and then we divide it by 3 simultaneously, and we get that MC equals to 3 2 times 2x over 3. So MC equals to 2 times 2x is 4x over 3. So je find out that MC equals to 4x over 3 units in its length. So I write it down. MC equals to 4x over 3 units in its length. Those two expressions are also equal to each other, so we get equation 2 from those two expressions that are equal to each other. According to equation 2, we get that dm over x equals to 3 halves. Get dm over x equals to 3 halves. Here we multiply this equation 2 by x, and we get that dm equals to 3x over 2 units in its length. dm equals to 3x over 2 units. So I write it down. dm, this is side dm, that is equals to 3x over 2 units in its length. In the next step, I'll copy this whole right triangle BMC in a new page, and we will implement the Pythagoras theorem on this whole right triangle BMC. BC equals to x units in its length, MC equals to 4x over 3, and the hypotenuse BM equals to 2 units in its length according to what is given as the question. Here by PT, evaluation for Pythagoras theorem. This is the right triangle BMC that I copied from the original drawing. This right triangle BMC according to the Pythagoras theorem, BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equals to BC squared. BC is x, therefore BC squared is x squared, plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we should find out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared equals to 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total 4x over 3 squared equals to 16x squared over 9. So 4 equals to x squared. So we multiply x squared by 9, and then we divide it by 9 in order to have a common factor of this expression, and we get that 9x over 9 plus 16x squared over 9 equals to 4. So 9x squared plus 16x squared is 25x squared over 9 equals to 4. 25x squared over 9 equals to 4. Here we multiply this equation by 9, and we get that 25x squared equals to 9 times 4 is 36. So here we divide this equation by 25, and we get that x squared equals to 36 over 25. So here we take a root out of this equation, and finally we get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, x equals to 6/5. X equals to 6/5. So BC equals to x, and x equals to 6/5. AD equals to 2x, so it is 2 times 6/5. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid? What is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, we know that the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. Here the two parallel bases are AD and BC, so it is AD plus BC times the height. The height is DC. Why the height is DC? Because of the fact that DC creates 90 degrees with the base AD, and DC also creates 90 degrees with the other base BC. Therefore AD is the height, and therefore AD is the height. Again, DC is the height. Therefore DC is the height. Again, DC is the height because it creates 90 degrees. It creates 90 degrees with the base AD, and it also creates 90 degrees with the base BC. So DC is the height divided by 2. So repeat again, we should find out that the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AD plus BC, times the height DC over 2. AD equals to 2x plus BC. BC equals to x times the height DC. DC in total equals to 3x over 2 plus 4x over 3, all divided by 2. So in total, if we found out that the area of trapezoid ABCD is equal to 2x plus x plus 3x over times 3x over 2 plus 4x over 2 divided by 2. 2x plus x is 3x, so we have 3x divided by 2. In the brackets we have 3x over 2 plus 4x over 3. So here we take out 6 as a common factor from those two expressions, and we do it by multiplying both the numerator and the denominator of this expression by 3. So 3 times 3x is 9x, and 2 times 3 is 6. Likewise, we will multiply both the numerator and the denominator of this expression by 2, and we get that 4x times 2 is 8x, over 3 times 2 is 6. By doing this operation, we actually get that 6 as a common factor. We took out 6 as a common factor from those two expressions. In total, the area of trapezoid ABCD equals to 3x inside the brackets, so it is 3x over 2. Inside the brackets we have 9x plus 8x is 17x divided by 6. So here we will divide both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is x, so in total in the numerator we have x times 17x, and we have to divide also the denominator by 3. 6 over 3 is 2, so in total in the denominator we left with 2 times 2. So in the numerator we have 17 times x, and in the denominator we have 2 times 2, that is 4. So in total we have found out that the area of trapezoid ABCD equals to 17 over 4 times x. But we have already found out that x equals to 6/5. So we substitute x by 6/5 in this expression, and you get that in total the area of trapezoid ABCD equals to 17 over 4 times x. So x is equals to 6/5, so we substitute x by 6/5, and we have x again, so we substitute again 6x by 6/5. So in total the area of trapezoid ABCD equals to 17 over 4 times 6/5 times 6/5. So 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9, because 6 times 6 over 4 is 9. And we get that in total the area of trapezoid ABCD equals to 17. In the denominator we have 5 times 5, that is 25. And in we substituted 6 times 6 over 4 is 9, so we substitute 6 times 6 over 4 by 9. So in total we found that the area of trapezoid ABCD equals to 17 times 9, that is 153 over 25 square units. In terms of numbers, the area of trapezoid ABCD equals to 6.12 square units. And that is the answer to the second question. I repeat again. We actually found out that the area of this trapezoid ABCD equals to either 153 over 25 square units. In terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. So we finish with the second question. In the next step, I summarize the lecture. We start with the first question, of course. Malcondet, what is a trapezoid? A trapezoid is a quadrilateral. A trapezoid is a quadrilateral with one pair of parallel sides. Because again, a trapezoid is a quadrilateral with one pair of parallel sides. And normally we have a quadrilateral ABCD. And because of the fact that in this quadrilateral ABCD, side AB is parallel to side DC, this quadrilateral is defined as a trapezoid. The two parallel sides, that is to say AB and DC, are defined as the bases of this trapezoid ABCD. And if we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid ABCD will be equal to the sum of its two parallel bases, that is to say A plus B times the height h over 2. So the area of a trapezoid equals to the sum of its two parallel bases, that is A plus B times the height h over 2. The height h must create 90 degrees with the two parallel bases. So, in the first question, we have to find out the area of this trapezoid ABCD. It is given us the question that the perimeter of this trapezoid ABCD is 16. The perimeter is the sum of the lengths of all the sides of the trapezoid. In this trapezoid ABCD, it is AB plus AD plus DC plus CB, and it is given us the question that is equals to 16. In addition, we know that AB equals to 2 units in its length. So, according to what is given as the question, AB plus AD plus DC plus BC equals to 16. AB is 2. We define the length of AD as A and the length of DC as B. And because of the fact that BC equals to DC according to what is given as the question, BC must also equal to B. AB is 2 according to what is given as the question, AD is A according to our definition, DC is B, BC is B, and this equals to 16 in total. That is to say, 2 plus A plus B equals to 16. We subtract the 2 from this equation and found out that 16 minus 2 is 14. So A plus B, that is A plus 2B equals to 14. Here we subtract 2B from this equation and found out that A equals to 14 minus 2B. So the length of side AD is A and A equals to 14 minus 2B. Okay. In the next step, we did a construction. That is to say, from the vertex B of this trapezoid ABCD, we draw perpendicular on DC. Again, from the vertex B, we draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, created quadrilateral ABDM. Inside quadrilateral ABDM, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ABDM, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral ABDM as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle ABDM, side AB must be equal to the opposite side DM, but AB is 2 according to what is given as the question. AB is 2 according to what is given as the question, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle ABDM, side AD must be equal to the opposite side VM. But AD is 14 minus 2B, therefore the opposite side VM must be also equal to 14 minus 2B in its length. What is the length of this missing 9/7 MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, that is B according to our definition, minus DM. We just write down further, the DM equals to 2. So in total, MC equals to B minus 2 is in its length. MC equals to B minus 2. In the next step, I go with this right triangle BMC in the new page, and we implemented the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in this right triangle BMC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, this is the right triangle BMC, that is correct from the original domain. This right triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equals to BM squared. BM is 14 minus 2B, therefore BM is 14 minus 2B squared, and plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, if you found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. Here we open the brackets of this equation, and if you found out that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared. Minus 2 times 14 is minus 28. Minus 28 times 2B is minus 56B. And we have also plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. So in total, we should find out that B squared equals to 196 plus 4B squared minus 56B plus B squared plus 4 minus 4B. Here we have B squared on both sides of this equation, so B squared will get cancelled. After we cancel B squared on this side of the equation, we left with nothing, that is to say 0. While on the other side of the equation, we have 196 plus 4, that is 200. And we have also minus 56B minus 4B is minus 60B plus 4B squared. So in total, we should find out that 0 equals to 200 minus 60B plus 4B squared. Here we divided this equation by 4, and finally found out that 4B squared over 4 is B squared, minus 60B over 4 is minus 15B, and 200 over 4 is 50, and 0 over 4 is 0. So in total, we actually found out that B squared equals to minus 15B plus 50, B squared minus 15B plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And when we find out the value of x according to the following formula, x equals to minus b plus minus 4 to b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is small b. We have small b, that is the variable that we are looking for, and we have capital B, that is the coefficients of the quadratic equations. So they are totally different things. Okay, again, small b is the variable that we are looking for in our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0. So x equals to b, because b is the variable that we are looking for. The coefficient a equals to 1, the coefficient b equals to minus 15. It is capital B that is equals to minus 15, while small b is the variable that we are looking for. And the coefficient c equals to 50. The only thing that is left to do is to put this data in our specific quadratic equation. In this way we find out the value to put this data in this general formula. And this way we find out the value of the values of B, because B is the variable that we're looking for in our specific quadratic equation. So we did it, and we substitute x by b, because x equals to b. So b equals to minus b. Minus b, b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus b squared. B is minus 15, therefore b squared is minus 15 squared, that is 425. Minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4, times c is 50. So minus 4 times 50 is minus 200. So inside the root we have 225 minus 200 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in total, if we found out that b equals to 15 plus minus, inside the root we have 225 minus 200, that is 25. So inside the root we left only with 25 over 2. So b equals to 15 plus minus, the square root of 25 is 5 over 2. So here we have two solutions that are possible for b. We define the first solution for b as b1. And the second solution for b is b2. So the first solution for b is b1, that is equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b, that is b1, equals to 10. The second solution for b is b2, that is equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is 5. You know that AD is one side of trapezoid ABCD, and AD equals to A. It means that the length of side AD is equals to A units in its length according to our definition. So AD equals to A units in its length, and A itself equals to 14 minus 2b. 14 minus 2b is the expression for the length of side AD. So this expression is a length, and the length must be a positive number. So what is a positive number? A positive number is a number that's greater than 0. So in total we should find out that 14 minus 2b is greater than 0. Here we added 2b to this inequality, and finally found out that 14 is greater than 2b. Here we divided this inequality by 2, and finally found out that 14 over 2 is 7, and 7 is greater than 2b over 2 is b. So in total, we found out that b must be less than 7 units from one side, but from the other side, according to the first solution for b, b1 equals to 10. b1 equals to 10, but b must be less than 7. Therefore, this solution is an incorrect solution. We cancel the solution, the first solution, and we left only with the second solution for b, that is b2, that equals to 5. So we found out that b equals to 5. That is to say, DC that equals to b is equal to 5, or DC equals to 5, and AD equals to A, and A equals to 14 minus 2b. B is 5, so minus 2b is minus 2 times 5, that is minus 10. And 14 minus 10 is 4. So in total, we found out that AD equals to A equals to 4 units. The length of side AD is 4 units. Okay, our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of a trapezoid equals to the sum of its two parallel bases. In this case, it is AB plus DC times the height AD over 2. And again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC, times the height AD over 2. AB is 2 according to our definition. AB is 2 according to what is given in the question. DC equals to B, and B equals to 5. So DC equals to 5, and AD equals to 4. Repeat again, AB equals to 2, DC equals to 5, and AD equals to 4. So in total, the area of trapezoid ABCD equals to 2 plus 5, that is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14 square units. So if you found out the area of this trapezoid ABCD is equal to 14 square units. So finish the first question. In the next step, I presented you the second question and solve the second question of this lecture. The second question, our mission is to find out the area of another trapezoid with the same name. Okay, the name of the trapezoid is ABCD, but it is totally different trapezoid than the trapezoid of the first question. So this is trapezoid ABCD. Side AD equals to 2x units in its length, side BC equals to x units in its length. This is 97 AM, this equals to 3 units, 97 BM equals to 2 units. Those two angles are right angles, and this is again A and B, this is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define this angle as alpha. This is to say again BMC equals to alpha. So in the right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line DC at point M here, so here the sum of the angles must be equal to 180 degrees according to rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of this point M, we have this angle that is alpha, plus this angle that is 90 degrees, plus this missing angle, total the sum of the angles must be equal to 180 degrees according to rule 3. Therefore this first missing angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles on the upper side of DC at point M according to rule 3. So this missing angle equals to 90 degrees plus alpha. In the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this first missing angle must be equal to alpha. 1 equals alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. In the next step, we prove that those two right triangles are similar to each other according to angle similarity rule. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So in total, if you found out that all the angles of this right triangle ADM are correspondingly equal to all the angles of this right small triangle BMC, and therefore those two right triangles are similar to each other according to angle similarity rule. So if you found out that the big triangle in VA is similar, this is the side of similar to the right small triangle BCM according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. that AD over MC equals to DM over BC equals to AM over BM. AD is 2x, MC is the missing side, so we leave it as it is, DM is the missing side, so we leave it as it is, BC is x, AM is 3, and BM is 2. So in total, if you found out that 2x over MC equals to DM over x equals to 3 halves. Those two expressions are equal to each other, therefore we get an equation 1 from those two expressions that are equal to each other. So according to equation 1, we can find out that 2x over MC equals to 3 halves. 2x over MC equals to 3 halves. Here we multiply this equation by MC and finally found out that 2x equals to 3 halves times MC. Here we multiply this equation by 2 and then we divide it by 3 simultaneously and finally found out that MC equals to 2 times 2x over 3. So MC equals to 2 times 2x, so it's 4x divided by 3. So in total, we found out that MC equals to 4x over 3. MC equals to 4x over 3 is in its name. Those two expressions are also equal to each other, therefore we get an equation 2 from those two expressions that are equal to each other. So according to equation 2, we found out that dm over x equals to 3 halves. dm over x equals to 3 halves. Here we multiply this equation by x and finally found out that dm equals to 3x over 2. So this is side dm that is equals to 3x over 2. In the next step, I go with this right small triangle BCM in the new page and implemented the Pythagoras theorem in this right small triangle BCM. So this is the right small triangle BCM that is according from the original drawing. According to the Pythagoras theorem, in this right small triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus CM squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equal to BC squared. BC is x, therefore BC squared is x squared, plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we found out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared, and 4x over 3 squared is 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, 4x over 3 squared equals to 16x squared over 9. So 4 equals to, we have here x squared, so multiply the x squared by 9, and then we divide it by 9 in order to overcome factor with this expression. And finally found out that 4 equals to 9x squared over 9x squared. And we have also plus 16x squared over 9. And so 4 equals to 9x squared plus 16x squared is 25x squared over 9. So in total, we actually found out that 25x squared over 9 equals to 4. Here we multiply this equation by 9 and finally found out that 25x squared equals to 4 times 9, that is 36. So x squared equals to 36 over 25. Here we took order of this equation and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, x equals to 6 fifths. X equals to 6. So BC is equals to x equals to 6 fifths, and AD equals to 2x, so it is equals to 2 times 6 fifths. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. In this trapezoid ABCD, the two parallel bases are AD and BC. Therefore, it is AD plus BC times the IDC over 2. Because again, the area of this trapezoid ABCD is equals to AD plus BC, that is the sum of its two parallel bases, times the IDC over 2. AD is 2x, BC is x, and DC, the IDC equals in total to 3x over 2 plus 4x over 3. Okay, again, the IDC equals to 3x over 2 plus 4x over 3x over 2 and we, plus 4x over 3, all divided by 2. Here we took out 6 as a common factor from those two expressions. We did it in the following way by multiplying both the numerator and the denominator of this expression by 3. So 3 times 3x is 9x and 2 times 3 is 6. Likewise, we multiply both the numerator and the denominator of this expression by 2. This way, so 2 times 4x is 8x and 2 times 3 is 6. So in this way, we created 6 as a common factor from those two expressions. So in total, we found out that 3x over 2 equals to 9x plus 8x over 6. 9x plus 8x is 17x. So in total, in the numerator we have 13x times 17x, and in the denominator we have 2 times 6. Here we divided both the numerator and the denominator of this expression by 3, and finally found out that the 3x over 3 is x, so in total in the numerator we have x times 17x, and we have to divide also the denominator by 3. So 6 over 3 is 2, so in total in the denominator we have 2 times 2, that is 4. So, and in the numerator we have 17 times x times x. So we found out that the area of the ABCD equals to 17 over 4 times x. But we have only found out that x equals to 6/5. So we substitute x by 6/5 and other x by 6/5. So in total, we found out that actually that the area of the ABCD equals to 17 over 4 times 6/5 times 6/5. So it is 17. We have 6 times 6, that is 36, and 36 over 4 is 9. So instead of 36 over 4, we write down 9. So it will be 17 times 9, and 5 times 5 is 25. So in total, we actually found out that the area of the ABCD equals to 17 times 9 over 25. 17 times 9 is 153 over 25. So 153 over 25 is 6.12 square units. So in total, if you found out that the area of this trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers, it is equal to 6.12 square units. Okay? Thank you very much.